Yeah. So yeah, the brackets you can pretty much replace with do and end, and it just sort of works.
Okay.
Yeah. Do you have any Lisp background?
I don't.
No. Okay. Yeah. Okay. Cool. I guess we'll get going, even though they're not totally here yet. I mostly am worried about not having enough time if I wait too long. But I guess I'll just dive in.
Still 5 today. Is that right?
Oh no, sorry. 3:30, not 3:15. Never mind. It goes till 5:30, and then there's at 5:40 there's a closing keynote. But yeah, sorry, you were saying syntax is unfamiliar. Yeah, so pretty much everything in the language. This is going like. This isn't part of the main presentation. This is me killing time waiting. So this do end is always something multi-line, right? So when this, the AST, when this gets into the compiler, turns into literally a list of statements, right? So anytime you have this do end, you notice that they're inset, right? So I have a do end, and inside of that, a do end, and we can have progressively more and more of them, right? Elixir is homoiconic, so everything that you see in the syntax translates directly into the AST. Right. Yeah. And then actually this do with the colon is just sugar for this. Yeah.
Sees another statement that's like orphaned, it'll just give you a compile error like I was getting.
Yep.
Fun learning a new language today.
Yeah.
I didn't know what I was going to do until like 5 minutes before.
So well, I'm glad you're in this one. Yeah.
I was thinking of doing the crypto one since it was in Scala, but
right.
I just didn't want to learn too much math heavy stuff. You know.
Sure.
So I figured new language would be more helpful than relearning calculus.
Right. Yeah. Yeah.
So.
Well, and it's always fun to, like totally different syntax, different way of doing things, right?
Rethink about what.
Yeah. Yeah. And I mean, it is a lot to take in, even though it's like, we haven't done anything that complex, but you're having to absorb a lot of material, right? It's 6 hours. It's a lot, right? Yeah, for one day. But, you'll come out of this and, GenServer is probably the killer module from the standard lib. And it gets replicated all over the place. Like people just lift this and rewrite it in other languages. Yeah, so. So Roman, my friend who's giving the 6-hour rock-solid Haskell services, he basically took OTP, translated it into Haskell, and that's like half of his talk today.
Really?
Yeah. So, yeah.
So GenServer, is that the same thing as OTP? Is that the same thing?
Yeah. So OTP, Open Telecom Platform, kind of two halves to this answer. One is it's literally everything. The compiler, the VM, the language, the libraries, that whole package is OTP, officially. When people talk about OTP colloquially, it really means GenServer, agent, task, like the concurrent process-focused parts of the standard lib. Is when they'll say like, yeah, and with OTP it's really great. They don't mean Erlang, they mean these. Yeah.
Agents and all that. Yeah, it's a lot easier to use than the ACA actors that I've used before.
Yeah.
So I had a lot of issues with like, I don't know if it says like dead letters or something like that, but basically you could like spin up an actor and you'd actually like send messages to them, but they'd already be dead by that point.
Interesting.
So
yeah.
There was a lot of issues with that, where like weird errors where you try and spin up a bunch of actors. And it's not very costly like this. It's really easy to spin up like a bajillion of them.
Yeah.
But you get a lot of weird errors, especially in the code base that some of the stuff that my company has is kind of older. Still uses ACA actors.
Right.
There's still errors that pop up where it's sending letters to actors that have already died. Mailboxes that aren't expecting anything. So
right. Yeah.
It's not good.
Yeah.
Especially when you try to put in like financial transactions or whatever, and they're just going to.
Right. Yeah. So you could absolutely do that here. Like you can send Actually, no, you'd get an error if you tried to send to a process that wasn't running. Yeah, no, it would blow up. Yeah. Yeah.
So would it just keep retrying? Like if you send something in the mailbox, like you said, it was like a default 5-second timeout.
Yeah, it'll time out if it's waiting for something. So if it does like a handle call and you're waiting for a response, it'll time out after 5 seconds by default. But you can adjust that. Like if you know that this might be a long-running thing, you could say 30 seconds or whatever, right? Let me jump ahead. Oh, and I should probably unmirror these again. Let me jump ahead briefly here while we're waiting, and I can show you the other, because I don't think we'll have time to get past. I had some like supplementary material in case we blew through stuff. But yeah, while we're waiting, so supervision trees are pretty cool. There's two kinds. There are monitors, which can watch. They shouldn't have any other code. They should just sit there and watch a process. And if it goes down, they'll have some automated behavior to say restart it, or who cares, or restart some other pieces. And that's with monitor and demonitor, right? It's unidirectional. Then there's links, which we've done every time we've said start link today. It's these bidirectional pieces. So I'm saying that these two are part of a system that should go down together, right? So one dies, the other should die. They set up like this, right? And you just say, here's the children to start up. And these are usually a GenServer. So when you say use GenServer, you can just push it into a worker and it'll just go. Yeah. And then I'm saying the strategy here, 1 for 1, is if it dies, just restart it forever. And then you can add more stuff to it as well. For like, if it dies, only let it die 4 times, or do incremental back off or whatever. Yeah. And so the idea is that your process is never down for good. It'll come back up, and you should be able to receive those messages.
You don't need anything else to manage.
Yeah.
You need what's running some other management system.
Exactly. Yeah. Now, if a process crashes, you may lose that message it was working on. So if it's critical, then yeah, you need to put things into a separate message queue that you know is solid, and check that it actually happened. And that's when,
Copies of it on the sender and the receiver.
or
Get a verification back to you.
yeah, exactly, then clear it. Or do everything with a handle call so that you're forcing to hear a response before you continue, and then clear that message out of your queue and then do the next thing. Yeah. So anyway, so let's actually get started with where we should be. Right. So yeah, we covered a bunch of this before the break. So there's my init with an OK. Initialized that. I just walked through this verbally. Forgot I had slides for this. That's handle call, which is synchronous and blocking on that process. And cast, which is asynchronous. Looks like that. The most common response is no reply. And info has the exact same messages as handle cast, the async one, but it's if nothing else matches, basically. And then that's the client API that we looked at right before the break. So again, cast, so do this asynchronously, and then do these two synchronously, right? I want to get a dump of the entire database. That's going to send a get all. And then we played with the DB a little bit. As a take-home exercise, if you're interested, because again, this will be, all these slides will be available online. You can do another version of a database that keeps all the history of all the values it's been set to in the past. Call it ScanDB. And I have an example implementation in Uprun of ScanDB when you push new values into it, you'll get back every previous version. But with a get, you'll just get the most recent. And so you can have a totally immutable database if you really want it. So let's actually write quick chat. Wrap up the day. Last chunk of 2 hours. So we're going to need a game plan, right? So if you remember way back to this morning, we had a limited amount of functionality, but we had a full messaging system, right? You could broadcast to everyone. You could send DMs. You could see a list of everyone that you're connected to, and this is the part that you didn't see, is that you're also forwarding messages onto others in case somebody's lost, they've disconnected, reconnected, and they don't know about everybody else yet. So the final client interface is going to look like this, right? We have start to start a process with that server, right? Which we've broken out the implementation for into .server, that pattern I was talking about before. And we're going to start it with self and then name it, so we don't have to process.register. We can just put a name in with chat. Again, in production, maybe don't name it, but this is just to keep it really easy to set up. We have peers, so quickchat.peers is going to call the chat process and with the message list peers. Message text is going to broadcast text to everyone. And DM, we have to specify who we're sending it to, but otherwise is pretty similar, right? So we're going to start with, Right. So we're just printing the messages. We're not going to hold on to them at all. If you wanted to create a database of the history, so next time you started it up, I mean, you could, but just for simplicity, we're just going to print them and continue. We're going to keep a list of known peers. When you send or receive a DM, we're going to record the address and forward that on to everybody else that we know. So the way to, instead of saying, connect to this person and getting a list, we'll just do that with a DM just for simplicity. Public broadcast, print the message to yourself and send it to everybody on your list. We're going to generate a unique ID, just a random string, to go along with that, so that, because you're going to be forwarding messages on to everybody else, if they get a message that they've already seen with, they've seen this random string before, they're not going to print it, they're not going to forward it on, they'll just ignore it. And that's how we're going to limit, so it doesn't, send to everybody forever. Right? It's a random string so that we don't have to have some global store of message numbers, right? Called a nonce. And then, when you receive a new broadcast, print the message, forward to all peers, and the one I missed on here was check if you already have that message registered previously. And then, if it's been registered previously, do nothing. So, in broad strokes, we have a handle call, which is synchronous. It's part of our client interface, and we're mostly going to use that to delegate to asynchronous parts of the internals. Right? So our client portion of this, when I say, message, hello world, that's going to be a call because I, as the caller of that, want to know that that happened, right? That's not fire and forget. I want to make sure this actually worked. Handle cast is going to do all the async stuff, and it's going to do the actual work for us. And then when we hear stuff from our peers, we're also going to do that over cast as well. Right? Because pretty much all of these can be fire and forget. If they didn't get the message, they're going to hear about it from somebody else, probably. So the flow of this graphically, right? So we're going to have there could be more people in this system. but we'll just start with 3, and then these lines are time. And the faces on the sides are who this one and that one know about. Okay. So it starts out with the scientist knows about astronaut because he has to be able to send her a message, right? Purple is a DM. When she does a broadcast, only knows about one person, so that's only going to get sent to one. Now, a new person joins by sending a DM in. The fact that she exists gets forwarded on here, and the fact that he exists gets forwarded to her. Now, when we broadcast, it'll always get forwarded on, and we'll just ignore it if we've seen this message before. There was a little bit of emoji in the demo version, so if you need to look some emoji up, there's always emojipedia.org. Let's look at our setup, and I encourage everybody to follow along if they want. If not, this is available in the first of the 2 repos that you cloned today. So we're breaking out the client and the server interfaces. So this is quickchat.server. This is going to live in /lib, because we set up that project, /lib /lib /quickchat/server.ex, just by naming convention. And then use GenServer. This makes adds @behavior GenServer and a few setup pieces that we would need for supervision trees if we wanted them. Yeah, so it's just going to enforce the interface for us. We'll then init with the owner. So if you remember back to when we had the start, it included self. So this is init with owner. And when we start up, we want to let ourselves know that we've started up. So we're going to write connected as whoever I am right now. Self is just short for node.self. And then because of the interface from GenServer, we're going to return OK and our state. Our state is 3 pieces. To I am, a map set, which is, it's just like a set. It's a list with no duplicate values. And we're just going to do that to give us automatic deduping. It works pretty much as you'd expect. You can put stuff in it, look at things, remove items. That's our nonces. So that's the random string that we have of messages that we've heard about in the past. And then this is our list of peers. If I hear about a peer twice, I don't care. I don't want to send them duplicate messages. I'm just going to stick it in my map set. You can think of this state as our session. You could also model this with a map so that you had, like a key value, owner, owner, nonces, this. This is more efficient and more idiomatic. My personal style when I'm writing is I stick things in maps. There's special kinds of maps called structs that have certain keys. But this is what you would see in 95% of people's code. All right, with that working, with that all saved, you can go into IEX supervised mix and genserver.start, like so. And you should say connected as no node at no host. Ta-da. So going back to that init, This bit is going to be a little bit of magic. I'll walk you through what it does. But we're going to do this to get the colorization and the emoji, like the little monkey covering its eyes, all of that in here. We're going to create a function called log, and instead of just putting, we're going to log text, sender, icon, and then color, which by default will be white. This list is what the ANSI formatter needs. And that's just straight out of the docs, copy paste it, and then with some string interpolation. And then if you io.puts one of these, it'll print with color and all that good stuff. So in this case, I'm saying log, no text, the sender is me, my icon's going to be a little plug because I'm connecting, and I'm going to do this in green. Looks like this. All right, got my little plug, no host at no host. Cool. And then we get back our OK and the PID. And a blank line. To request some data, we have our handle call with that list peers we were looking at earlier. This is the interface, same regular GenServer interface, right? We have a message, who it's from, and our current state. So session, because it's just what we're calling it. And it's pretty straightforward, right? I can take out of my session, because I have that triple, right? I don't care about the owner. I don't care about the nonces. I just want my list of peers. And I can do this equals session so that I still have this whole thing around. I'm going to reply with the peers. And my new state is the old state. It's just, it hasn't updated. That underscore in front of the from is because we don't use it, we don't care about it, we're just signifying that we're not going to use it. It doesn't really matter, you just get a like an info on the compiler. It's like, maybe you should put an underscore in front of that. And then yes, those. Make sense? So now when I go back to my terminal and I start and I get the PID, I can call GenServer.call, this server, list peers, and right now I don't have any peers. Okay. Because I want that to print as a list, because I don't care what data structure it's in as the user, I'm just going to say mapset.toList peers. Otherwise, it's the same as the last version. And this is going to give me an empty list instead. Public messages. So that MSG that we were typing in is going to delegate to this function. So we're going to say log, so that's our logger function, text to the peer that we're sending this to. So this is my message, right? And a little happy face. No reply. So I don't send anything back, which is why this is only 2 instead of 3. And then I have to update my state, my session. So my owner hasn't changed. I just leave that as owner. Mapset.put, the new nonce that I've gotten in my message, right, the random string, to those. And then peers is unchanged. But we also want to forward this onto our peers. We're going to be doing a lot of forwarding out to our peers. So why don't we write a forwarding function? So we'll stick the forwarding right here before we finish. This is what this function has to return, right, for the interface to work. So we'll put it right before that, forward. And it can look like this. For each peer, and address we'll look at in a moment too, send them the payload. Send them the whole message in this case. Now I can enum.each peers, right? Even though it's a map set, because it's something that can be turned into a list. Anything that can be turned into a list is enumerable, I guess. But yeah, we haven't defined this one yet. And that's what it looks like. So in some cases, we're going to be getting this as a string, some cases as an atom. We need it to always be a string. Is bit string. No, we need it to always be an atom, right? We're going to send it to chat at some room, which is the atom portion of this, right? So when I was saying chat at 192.168.1. Whatever I was at, 2, that was the chat and the 192, etc. Okay. All that this is doing, so this is address room twice, is I'm saying when this is a bit string, turn it into an atom, and then keep going. Okay. Deduping, because I don't want the same message over and over and over again, right? We have those nonces. So let's just wrap it in an if-else. So if it is a member of this map set, don't do anything, because I already have it. If it isn't, then do the normal behavior. Okay? Broadcast. So this is handle call, right? So it's the synchronous version. This is me, the user, telling the server to do something, right? I'm going to say broadcast some text from, and then we don't care about the, so this is going to be who I am and where I'm from. It comes as a tuple. Owner nonces peers. Log it out, because I want to see my own message get printed. I'm going to create a new nonce, which is just a random string of bytes. Forward on to my peers, including who I am, which I'm going to do as a string, which is why we have to later then turn it back into an atom, but do it as a string. Reply. Okay, that worked. Owner, and then put this into my list of known messages and don't update the peers. Why am I checking if this is being sent by the owner of this process, right? Why am I checking this matches this? Any ideas? Exactly, yeah. By default, anybody on the network will be able to send your process a message, unless you check this. This is us sending this forward on. That's the thing that we wrote a couple slides ago. So we're going to forward to our peers this message. So I'm cheating a bit for the demo again, right? Name chat. But we can say GenServer.start, our module, starting with ourself, name chat, call chat, broadcast hello. I print hello and go OK. And when I broadcast bye, I get back bye. I'm not getting anything else yet because I'm not connected to anybody. Which we can fix. This is my handle cast to add a peer. This is a cast because I want it to be fire and forget. So add peers, it can be many. And then I have my session again. Take the list that I'm getting back, get back the disjunction, I guess, between them, the difference between them. And then look at the size. If the size is 0, I don't have to do anything. Awesome, right? I have all the same ones. Otherwise, if I have any count other than 0, log that I'm now attached to X number of new peers, wave, put it in green, and then no reply. Don't change the owner, don't change the nonces, but add in more peers. These are my map set. This is if you just heard from somebody who sent you a DM that you've never seen before. You're going to get this newcomer message. Okay. We're going to handle cast on it, newcomer. So sorry, that's when I'm the person that you're hearing about. Don't do anything. Okay. Otherwise, right, because we have the two cases, we're going to forward this on to everybody else that there's a newcomer. We're going to log that this has happened. Add a peer, so we're going to interact with the back end of our server, right? And then update them. Say, put this as a new peer. And this address is the same address that we were using before. Right? That's the reuse. Now we have a little bit more functionality, right? We can alert that somebody new has joined. They haven't actually joined. I'm just sending the message directly, right, from within my session. And now when I list my peers, I actually get something. Private messages are pretty much more of the same. We've changed the emoji. The message is DM. And other than that, we're just going to handle cast that there's a newcomer. And we'll only log if we haven't seen this message before. Right? So add a peer and a public message, printed in a different color, different emoji. This is, again, a call, synchronous, command to send a DM to somebody with a certain text. Everything else is stuff we've seen before. Log it out in yellow so that you know it's yours. Create a new nonce. Do the same. Send it to the person with the DM. Not everybody this time, just the one. If you haven't seen this person before, add them to your list of peers, reply with an OK, and update both your nonces and your peers. And those should look familiar too, right? Because that's our private interface. Okay. So in this case, we have two processes. I'm giving them different names. Me and friend. I'm going to tell process me to send a DM to friend. Hey, are you there? And it's going to print that out. DM and send DM. Yeah, so this is the same. Now, oh right, yeah, so we disabled the don't listen to the same message. So now we can print out in the same session, but because they have different different PIDs, I'm sending it to them, and then they're going to see from me, from no node at no host, hello over there. We have a little bit of polish, which is that setup that we had at the very, very beginning, right? Because I don't want to have to call GenServer.start this module, these starting conditions with this name. I want to just say quickchat.start. We have all four of them now, and these are the things that we just implemented. It's this chat because that's the registered name of the PID. My public interface, list peers, broadcasts, send it DM. And you can test it locally by opening two terminal sessions with a different name. So in this case, it's chat room and chat room 2, I believe. Room and yeah, chat room 2. They can both start up. Because you run IEX twice, you actually have two versions of the beam running. And you can send messages back and forth locally. So you have this sitting in Quick Chat, the repo that you pulled down at the very beginning. You can implement all of these. We have a little over an hour. So add some commands for slash commands like in Slack to well, do a calculator, etc. Do subgroup messaging. Say, I only want to send this DM to a certain subset of people. Keep the message history. Push it into an agent or hold on to it. Implement multi-tenancy. And we haven't talked about type specs enough, but you could add tests because you have a test module. Or, if you're tired of that, you could write quick draw, whichever you prefer. But that's your exercise for the next little bit. Cool. Or we could talk about supervision trees. It's up to you.
Okay, welcome to chat thing.
Chat? Cool. All right. One cool thing I've seen somebody do the last time around this session with slash commands, or time before, last time, they had a slash command to add an anonymous function. And so you could set arbitrary functions, which is kind of cool. Yeah. Anyone has questions after the fact? I'm pretty easy to find. It's just hello@myfirstandlastname.com or Xpeed basically everywhere. I'm totally happy to look over people's, early work, solutions to things that you've been working on today. If you have questions, further resources, books to read, all of that, totally happy to help out.
Thanks so much.
Yeah, thank you.